This one and Adiola, your chemistry tutor. Now, welcome to Learn Chemistry with Emerald. In today's class, we look at how we solve for oxidation number. Of course, you know that oxidation number is the number of the total number of electron an atom will gain or lose in order to become a neutral atom, or the total number of electron an atom will gain or lose in order to combine chemically with another atom. Okay, so there are basic rules in solving for um, oxidation number. There are a lot of rules, but I've picked some basic rules. Number one of them is the algebraic sum of all the charges must equal to 0, especially for a neutral compound. For a neutral compound, that means a compound that does not carry any charge, whether positive or negative. For that neutral compound, the algebraic sum of all the charges that's in that compound must be equals to 0. Another rule is that the oxidation number of any free element in terms of atoms or molecule. For instance, H2, for H2 the oxidation number is 0 as at that moment, unless it is in a compound. Sure, you understand? So this is another rule. For any free element, whether atom or molecule, the oxidation number is 0. And then the third one is the sum of all charges for an ionic compound equals to the charge it is carrying. An ionic compound is a compound that is carrying either positive or negative. It could be a cationic compound, or it could be an anionic compound. So if you are having a compound that is carrying charge, the algebraic sum of all charges in that compound must be equal to the charge that the compound is carrying. Now let's look at some example. These are jam questions. Let's look at some example here. Find the oxidation number of carbon in Na2CO3, chromium in K2Cl2O7, and manganese in MnO4 minus. Now let's solve each of them. Now you have Na2CO3 is a neutral compound, it's not carrying charge. So you're having 2Na because it's having 2 plus C plus 3 to bracket O, and everything must be equal to what? 0 according to rule 1. Okay, now it is now for you to know the oxidation number of all the elements. I recommend that you go and learn the oxidation number of elements 1 to 30, and then the oxidation number of all the radicals like CO3 2 minus, NO3 minus, ClO3 minus, etc. So go and learn the oxidation number of the elements, both metals and non-metals, and the radicals. It's very important. So the oxidation number of sodium is +1. Sodium is a group 1 element, so you can say 2 multiplied by +1, right? Plus, you are looking for the oxidation number of carbon in this compound, and plus 3 into bracket. Oxidation number of oxygen is -2. Oxygen is a group 6 element, so you have -2, everything equals to 0. Then 2 times +1 will give you 2. That's 2 plus C minus 6, because you are going to have 3 times -2 will give you -6. Everything equals to 0. Then C is equal to 0 minus 2 plus 6. Then C is equal to +4. So the oxidation state of carbon in this is +4. The oxidation state of carbon in this is +4. So you are going to have, and that's why the name of this is sodium triisocarbonate 4. Sodium triisocarbonate 4. So that's one. Number 2, we look at K2Cl2O7. Now the same principle applies. You are going to have 2K. So I will just read directly now. 2 into bracket 1, because potassium is 1, plus 2Cl, because chromium is Cl. Then plus 7 into bracket -2, everything is equal to 0, because oxygen is -2 and it's having 7 here. So you are going to have 2 plus 2Cl minus 14 is equal to 0. Then 2Cl is equal to 0 minus 2 plus 14. You are going to have 2Cl is equal to 12 minus 2 plus 14 is 12. Divided everything by 2, then Cl is equal to plus 6. So that's why you have potassium heptaoxodichromate 6. Potassium heptaoxodichromate, because it's having 2 here, dichromate 6. This is the one for here. So let's look at the last one. So for the last one, you can have we can clean this place. Let's quickly clean this place. Now for the last one, you can now have you are doing MnO4 minus. You are doing MnO4 minus. So don't forget that rule 3 says that for ionic compounds is equal to the charge that they are carrying. Okay, the ionic compound is equal to the charge they are carrying. So if you look at that very well, you can say that we are looking for Mn here. So Mn plus 4 into bracket minus 2 is equal to minus 1, because oxygen, the oxygen number of oxygen is minus 2 and it's having 4, so 4 times minus 2, and then the charge is carrying is minus, so that's minus 1. So you are going to have Mn minus 8 is equal to minus 1. Mn is equal to minus 1 plus 8. Mn is equal to plus 7. So the oxidation state of manganese here is plus 7, and that's why you can call this one tetraoxomanganese 7 ion, because it's having a charge. There must be ion here. So this is tetraoxomanganese 7 ion. So the first one is sodium triazocarbonate 4. Sodium trioxocarbonate 4. The second one is potassium heptaoxodichromate 6. Potassium heptaoxodichromate 6. And the last one is tetraoxomanganate 7. Tetraoxomanganate 7 ion, because it's having a charge. I hope you learn one or two things from how to solve calculate for oxidation number in compounds. If you have learned this, kindly share the video and continue to learn chemistry. Àwọn yóò ní sẹ́ǹsì ni.